Hello, here is a screencast about calculus with the TI36x Pro. So let's take a look first about tangent slopes. So here's a question on right here on written out on the iPad, and here it is right here. What is the tangent slope for f of x equals x squared plus 6x over divided by x minus 5? So we know that's a rational function. It's a fairly complicated function, but we want to figure out what is the slope of the function at x equals 10. So this is really asking us to evaluate the derivative at x equals 10. So here's how we do that, folks. There's a few ways to do it. So if I go on to here, one of the things I can do is it has a d by dx button. So right up near the second button, so I press second and then d by dx, and I can enter in the actual function. And what I can do is I can enter in that function, which would be x. Actually, I guess let's delete that because I want to put in a fraction. So it's going to be x squared plus 6x divided by x minus 5, and I want to figure that out at x equals 10. So that calculation right there will give me the slope of the tangent at that point. So d by dx means calculate the slope of the tangent to the curve, x squared plus 6x divided by x minus 5 at x equals 10. So what we would say is, the way you write this is that f prime at 10 equals negative 1.2. So it's a fairly flat slope. I'll maybe highlight that. It's a fairly flat slope at 10 of negative 1.2. And then I could sub in, I could figure out the y value at 10 if I wanted, and I could get the equation of the tangent. Now there are other ways to do this. I can actually make, if I go into the table feature, I can actually create a function that would give me the derivative. So for example, I can type in now d by dx of, same thing, and I'm just going to do, I'll just do x squared for this, or 3x squared. 3x squared, and I'm going to do that for x equals all x. So this is an interesting way to do it, okay? So that means for every single x, what's the derivative of 3x squared? And we know the derivative function for this, or the slope function, is going to be 2 times 3, 6x. But let's just see. So I get that, and if I do that, I can start at 0. Oops, I can start at 0, and I can go up by steps of 1. And let's see, I'm going to go up and over and hit auto, hit calc, and look at that, I can get, so at 0 the slope is 0, I'm at the vertex, that makes sense. At 1 it's 6, x equals 2, the slope of that curve is 12, 18, and so on. So I've actually got a derivative function here, okay, and I can do that with this calculator. So it's giving me the slope at all those points. So I could have gone, let's see, what is it at, oh, this is not the same function. But at 10, in this case, 10, the slope of 3x squared at 10 is 60. 3x squared is 6x. 6 times 10 is 60. That makes perfect sense. I can do some other things too if I use it this way. Say I want to find the vertex. I can go into the solver. So second function number solve, and I'm going to look for when f at x is worth 0. Right, so that's going to give me the well, actually, yeah, we can do that. I'm going to solve for x, and if it works, it should give me x equals 0 is where the slope of that function is 0. Now, it takes a little bit longer to solve these functions. There we go. Yeah, x equals 0. I might want to figure out, well, when is the slope worth? If I go back, I can figure out when is the slope 100 at what x value. and it'll give me that as well. So again, it takes a little while. So I'm asking it because the function that I have in there is d by dx of 3x squared. So there we go. When x equals 16.6 repeating is when the slope is worth 100. Okay, so that's working with slopes. And you could, anytime you want to get a rate of change. So how quick is something changing at a certain point in time? Or if you're given a rate, you can figure out the x value. So now that we've done that, let's take a look at accumulation. So the rate of snowfall in centimeters per hour is r of x equals 12x plus 6. So how much snow accumulates between 4 hours and 6 hours? So the storm clearly starts at 0 hours, and we want to know how much it accumulates. So in this case, we no longer have, we're not doing derivatives, we're doing the integral, so area under the curve. So another way of asking this is what's the area under the curve between 4 and 6 hours, if this right here is our rate function. So the snow starts coming down at 6 centimeters an hour, but it grows by 12 centimeters per hour every hour. So let's look at this. So if again you go from the second button and you go down to here, what this is this is an integral between the lower and higher limits, so between 4 hours and 6 hours, and the function is 12x plus 6. All right, dx means I'm integrating with respect to x, so that's how much accumulates if the rate function is 12x plus 6. And I hit enter, and it's 132 centimeters of snow. That would be quite a doozy of a storm. So we would put the integral of 6 to 4, or 4 to 6 rather, of 12x plus 6 dx equals 132. Now this is another one that we can put this function in a table. So we do the same thing again, edit the function, and let's clear that one out. And in this case, I do second function, integral. And in this case, I'm going to go from 0 to x. Right? So I'm going to start at time 0, and then to any value x, and it's going to be 12x plus 6. So it will tell me how much has accumulated. So I'm just going to go back and show you that again. So it goes from x to 0. You can see my upper limit is x, my lower limit is 0. So that means how much snow accumulates between the moment the storm starts at time 0 to any time x. And so I can go down here, I can hit calc, and I can have my table. I can go back and figure out how much snow accumulates at 4 hours. It's 120 has accumulated. So let's look at it and see if it works out the same way. So f at 4 in our case was 120, and then f at 6 was 252 centimeters. If I subtract those, 252 minus 120 equals 132. So it does work. I can do that. So if I wanted to do that, for example, outside of this, I would hit second and quit. I can use my function notation, and I can say f at 6, which represents the area under the curve from 0 to 6, and take away table function f at 4. So that would give me the accumulation at 6 hours less the accumulation at 4 hours, which would give us the accumulation between 4 and 6. So you can see you get the answer that way as well. So I just wanted to show you there's a variety of ways of doing this, and they all they work in each way in turn. So that, folks, is how you do both integration and differentiation with the TI36x Pro.